Welcome to the Explainer. Today, we are opening up the examiner's playbook to absolutely master Section 2.2 of the Cambridge Information Technology syllabus. We're talking about interpreters and cross-compilers. And listen, we are looking at this topic today through a very specific, highly strategic lens. We're calling this session the fashion designer approach to your Cambridge exam strategy. Now, why a fashion designer? Because just like a master tailor, you need to tailor your answer to fit the exact shape of the question perfectly. You can't have any loose threads. You can't have any wasted material. Every single stitch needs a purpose. Whether you're tackling IGCSEs under syllabus codes 417, 478, or 2210, or you're pushing into those really advanced AS and A-level territories of 9618 and our main focus for today, 9626, the underlying strategy remains exactly the same. Let's set the scene. You're in a high-pressure exam environment. The clock is ticking. You turn the page. On the left side of our hypothetical exam hall, we have a student named Alex. Now, Alex is a hard worker, really knows the textbook, but when the pressure hits, Alex overloads their answers with raw computer science facts. They just start spilling every single detail they've ever memorized about interpreters onto the page, but there is absolutely no analysis. Zero. On the right side of the hall, we have Sam. Sam looks at the clock, gets completely overwhelmed, rushes the process, and entirely misses the command word requirements of the question. Sam just starts writing bullet points. Both of these answers end up fundamentally flawed. They come back completely covered in red pen marks from the examiner. And today, in this session, we are going to fix that. We're going to transform those red marks into green check marks.
Let's dive straight into the deep end here, because this exact quote pulled from senior examiners highlights the massive stakes involved. The difference between a B and an A star isn't just about knowing the basic definition of what an interpreter is. Anyone can memorize that. It is all about understanding the actual uses of system software in specific, real-world contexts. Let's look back at Alex and Sam's answers from our opening challenge to really understand this. The past paper question asked them to evaluate the use of a cross-compiler versus an interpreter when developing software for a smartphone. Okay, pretty standard question. Alex wrote, "An interpreter translates high-level language one line at a time, while a cross-compiler creates executable code for a different platform." Now you might be thinking, hey, that's entirely true. And you're right, it is true. But here is the critical flaw. It's just a dictionary definition. It is absolutely not an evaluation. The result from the examiner? A painfully low 2 out of 8 marks. All that studying, wasted. Then we look at Sam. Sam wrote, "Interpreters are good for debugging. Cross-compilers make phone apps." Sam rushed. Sam gave incredibly vague bullet points instead of a structured logical argument. Result? Just one single mark. If you do not know exactly what the examiner is hunting for, you are basically throwing marks out the window. You have to tailor the answer.
Here is our strategic roadmap for today's session, structured exactly like the logical reasoning the syllabus demands from you. We'll hit the examiner's secret, build up your core principles, walk through the procedural framework, dive into the critical analysis matrix, and finish with the top examiner warnings so you don't fall into the common traps.
Section 1. The examiner's secret. Decoding the A star. Let's get into the mindset of the person grading your paper.
Now, what is really fascinating here is the vivid contrast between what students think they are supposed to do in an exam versus what the examiners actually prioritize and reward. Students aim for superficial breadth, listing off generic facts and relying on rote memorization. Examiners are desperately searching for analytical depth. They want to see logical, structured reasoning applied to completely unfamiliar contexts. To get that A star, you have to decode the command words. Words like evaluate, compare, and analyze are the keys to unlocking this analytical depth. When the command word is evaluate, you simply cannot just list facts. You have to use a structured approach. And top students use the PEAL framework. That stands for point, evidence, explanation, link. It is a total game changer. Point, you clearly state your argument right out of the gate. Evidence, you provide hard technical fact about the interpreter or cross-compiler to back it up. Explanation, you detail exactly how this fact impacts the specific scenario given in the prompt. Link, you tie it directly back to the final decision or the command word. For example, a student showing true analytical depth will make a point about execution speed. Then, for evidence, they'll state that compiled code runs natively and directly on the target hardware. For explanation, they'll detail how this specific trait preserves crucial battery life on a mobile device because the processor isn't wasting energy translating code on the fly. Finally, for the link, they tie it back to why a cross-compiler is the superior choice for final commercial deployment. That is exactly what examiners are looking for, no loose threads.
Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Moving right along to Section 2, Mastering Core Principles. This is where we build the theoretical architecture that will hold up your analytical arguments.
The most absolutely crucial point to grasp here is that top-performing candidates do not just memorize definitions. They do something much more advanced. They forge cross-topic connections, and they apply established principles to completely unfamiliar contexts. Let me be clear. Precise definitions are your starting line. They are not your finish line. You have to deeply understand causal relationships. Think about it like a chain reaction. For example, because an interpreter translates and executes source code line by line, therefore it halts at the very first syntax error it encounters, which causes it to be highly effective for initial debugging by a programmer, but incredibly disastrously inefficient for distributing a final commercial product to an end user. You see how one fact logically leads to the next? That is a causal chain. Furthermore, the principal examiner reports continually highlight that candidates who make cross-topic connections achieve significantly higher marks. What does that mean? It means linking the concept of cross-compilers directly to hardware architecture differences or network distribution limitations. They want to see you apply this knowledge to completely unfamiliar contexts. They're not just going to ask you about a generic desktop PC. They might throw a curveball and ask you to justify the use of a cross-compiler for programming a tiny embedded system hidden inside a smart washing machine. You have to be able to adapt your knowledge to that washing machine. You have to realize the washing machine doesn't have the memory to run a compiler, so the compilation must happen on a different machine first. That's the core principle in action.
Whenever you sit down and see a question targeting Syllabus Section 2.2, I want you to remember that your conceptual framework must rest heavily on systematic analysis and evidence-based reasoning. This number right here, it isn't just a placeholder in a textbook. It is a psychological trigger. When you see a question on translation software, your brain needs to immediately switch out of memorization mode and lock into systems logic mode.
Section 3, the procedural framework, the standardized sequence. This is how we actually execute that systems logic on the exam paper. What we have here brilliantly illustrates the standardized sequence you must strictly follow to extract data, interpret relationships, and present your evidence-based conclusions. We like to call this the computer science success blueprint. It's a 5-step process. Let's do a little interactive speed writing challenge in our heads. Let's walk through these 5 steps to rewrite Alex's previous flawed answer about smartphone development, and let's imagine we have a 60-second timer ticking down. Step 1. Identify key elements. We scan the prompt and pull out smartphone platform and development phase. Step 2, apply relevant principles. We immediately bring in our Peel framework. Step 3, execute analysis. We start writing our perfectly tailored answer. Point, a cross-compiler is absolutely essential for the final deployment of the smartphone app. Evidence, it translates code on a host machine, like a powerful desktop PC, into executable machine code specifically designed for a different target architecture, such as the smartphone's ARM processor. Explanation, the smartphone inherently lacks the massive processing power and RAM required to run a full compiler natively. Link. Therefore, utilizing a cross-compiler allows developers to leverage the heavy resources of a PC to create highly optimized, fast-running software tailored specifically for the restricted mobile hardware. Boom. Time's up. Do you see the difference? By moving systematically step-by-step through this framework, we naturally construct a flawless A-star answer. We turn those red marks into green check marks.
Now this brings us to a massively important concept straight from the examiners themselves, the method mark strategy. Understanding this can and will absolutely save your grade. In these complex, high-value questions involving system software logic, examiners are explicitly looking for your working out. They are evaluating your thought process. If you write down a valid assumption and you explain your technical reasoning step by step, using that Peel framework, but perhaps you make a slight misjudgment on the very final recommendation or conclusion, you do not score 0. Let me repeat that. You do not score 0. You pick up valuable method marks for the logical steps you took along the way. In computer science exams, the process is just as valuable, sometimes even more valuable, than the final destination.
The examiners literally put out alerts emphasizing this exact point year after year. If you break down the problem systematically but get the final answer wrong, your visible working out is what salvages those crucial marks. You have to leave a clear, undeniable paper trail of your computer science logic. Stop scrolling, subscribe to our YouTube channel Ace the Exams, at Ace the Exams IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @Ace the Exams IGCS and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, let's transition into Section 4, the critical analysis matrix.
The evaluative loop. This is where we separate the top-tier candidates from the rest.
By internalizing this deconstruct, solve, evaluate loop, you ensure that every single answer you write questions assumptions and justifies decisions with concrete, undeniable evidence. Let's imagine a data scan challenge. You are presented with a complex chart showing translation times versus execution speeds across different hardware architectures. You have 60 seconds to extract the trend. The deconstruction phase requires you to look at that data and realize the core trend. Cross-compilers trade heavy upfront development time on a host machine for incredibly high-speed execution on the target machine, making them the ideal choice for a commercial release. Similarly, when evaluating scenarios, you need to be able to spot flaws quickly. Let's do a Find the Flaw challenge. Imagine a sample paragraph that says, the cross-compiler is downloaded onto the smartphone so it can compile the app. Did you catch the flaw? Remember that a cross-compiler generates the executable on a host PC. It absolutely does not run natively on the target device. Believing a cross-compiler runs code directly on a smartphone is a fundamental misunderstanding of the translation environment. If you write that, the examiner will instantly deduct marks. You have to use the evaluative loop to catch those logical errors before your pen even hits the paper.
Section 5. Top examiner warnings. Don't lose easy marks. Now for the real insider secrets. Let's review the top mistakes pulled straight from the Cambridge Principal Examiner reports.
I need you to pay incredibly close attention here, because losing marks to vague answers or completely ignoring the specific context of the prompt is the single most common trap students fall into regarding interpreters and cross-compilers. The reports state it clearly every single year. Students hemorrhage marks by providing generic textbook definitions that blatantly ignore the given scenario. Let's look at another context. If the exam question is asking about an internet-connected smart thermostat, you cannot just talk about computers in general. You need highly specific details tailored to that device. The cross-compiler is necessary precisely due to the thermostat's severely limited RAM and its low-power CPU. It physically cannot host its own translation software natively without freezing or crashing. Therefore, cross-compiling the software on a robust desktop environment first ensures that the tiny embedded system inside the thermostat receives a lightweight, highly optimized, pre-compiled binary that it can execute immediately without any translation overhead. That is exactly how you avoid vagueness and accurately apply the required context. It's the fashion designer approach, perfectly tailored.
To avoid that second, massive trap of losing easy marks, you have to make sure you strictly adhere to presentation conventions and terminology. You are developing the professional skills required to clearly communicate complex system software knowledge. There are 3 ultimate rules in our final system that guarantee top marks. Rule 1 is command word decoding. You must know exactly what evaluate or analyze or describe specifically demands from you. Rule 2 is Peel framework application. Commit to me right now that you will never write a loose, unstructured fact in an exam again. Rule 3 is the time management matrix, which includes checking your terminology. Use the correct professional technical vocabulary. You say executable machine code. You never say computer instructions. You say target architecture. You don't say the other machine. Precision is everything.
Before we wrap this all up, I want to give you a very quick, highly effective memory hack for your studying. Build vivid, visual stories to encode these complex system software concepts so they instantly and automatically pop into your mind during the stress of the exam. Try this. Imagine an interpreter as a live, frantically working United Nations translator. They're standing right next to you, whispering into your ear line by line exactly as someone speaks. It's fantastic for fixing misunderstandings immediately on the fly, which is why it's great for debugging, but my goodness, it is a very slow way to have a conversation. Now contrast that. Imagine a cross-compiler as a massive, heavily industrialized factory sitting on one side of a wide river. This factory takes in raw materials, does all the heavy lifting, builds a fully functioning, incredibly sleek sports car, and then it puts that complete, ready-to-drive car on a ferry and ships it across the river to a tiny little island. Now, on this island, there are no factories, there's no heavy machinery, there are only roads. The island is your target device, like the smartphone or the thermostat. It doesn't need to build the car, it just gets in and drives it instantly at top speed. If you build these strong visual stories in your mind, you will literally never confuse their core functions again.
I am going to leave you with this provocative question as you dive back into practicing your past papers. Are you just memorizing superficial facts, or are you truly, critically analyzing the context to secure that A-star? Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.